Okay, welcome back. Today we're going to talk about functions, but before we do, I want to draw your attention back to our discussion of computational thinking for a moment. When we talked about computational thinking, particularly on this side of things, we talked about the abstraction, which means we're going to ignore the details and we're just going to think about the key features of a problem, of a particular step of a problem. And then we're going to go to algorithmic thinking, sequencing, which means we're going to sort of determine the steps for putting things together. A classic example of this is think about how might you instruct somebody to make a peanut butter and jelly sandwich. You might ask them to get out 2 pieces of bread. You might then say, okay, now you want to get out the peanut butter, get out the jelly, get out a knife, spread peanut butter on one side, spread jelly on the other side, put it together, and you've got a peanut butter and jelly sandwich. Then you might think to yourself, okay, well, what if I instead want to make a whole bunch of peanut butter jelly sandwiches? Well, we have something for that. We have something called loops for that, right? We could loop over the peanut butter and jelly sandwich and code, instructions, sequence, whatever you want to call it. We could loop over that a lot of times. But what if we wanted to be able to make sort of like any kind of sandwich, right? Well, then we want to sort of look at our abstraction, meaning, does it matter if the sandwich has peanut butter, jelly? Does it matter what kind of bread it is? Or can some of the instructions be abstracted? Can they all sort of be the same, right? Kind of like put the 2 outer pieces of bread or what have you on a plate, put the toppings inside, close it up. And you might be able to use those instructions over and over again and just sort of insert different things that you might put into a sandwich. You could even get crazy and call a hot dog a sandwich or something, right? So being able to abstract away from the details and then sort of thinking about how we might sequence even the abstracted things into step-by-step instructions is like a really valuable step for us in our computer science work. So, how do we then think about encapsulating that code? How do we think about taking a block of code and kind of pulling it out from the larger programs we've been writing? Because up till now, we've been writing things that are all procedural, right? Let's take a look at our calculator, for instance. This goes step by step through the instructions. The first line happens first, the next line happens next, so on and so forth, there on out, right? So that is what we call procedural programming. It's happening one step at a time. But sometimes we want to break away from that. We want to be able to have some things happen multiple times at different places. And to do that, we use these things called functions. Here are some things I want you to know about functions. Oops, not while loops. Functions. Here we go. So first of all, functions are a way for us to separate and reuse code. We're going to separate our code into what are called functions, these blocks of code, and then we're going to be able to reuse them multiple times in our program. Functions accept data, we call that parameters, and can return data, right? So if you were to make our sandwich making function, our sandwich making function might accept things like what goes inside the sandwich, types of bread, condiments, and it could return a fully fledged sandwich, right? So it would take ingredients and return a sandwich. It can take data, parameters, and return data. Functions are defined and then they can be called repeatedly. So there's sort of 2 steps to a function. There's the defining of a function where we say what the function is going to be. We actually write the block of code. But then there's the calling of the function where in our code or in our scripts later on, we actually call back to the function and use it over and over again. And then finally, I wanted to point out that we've actually been using functions already lots of times. We've been using what we call built-in functions. Print, from the very first lesson, is a function. It's a built-in function. It's part of the standard library in Python, right? So it is a function that is built in and it accepts a parameter, accepts what you want to print to your console. Those are built-in functions. What we're going to start working on are what we call user-defined functions, right? You and I are going to define the function and then call the function. So let's go ahead and start by looking at the syntax for a function, how we define a function, and then actually writing our own function. So we're going to start another Python file. Click on our button here, and we're going to call this functions.py. And let's start by looking at the syntax for defining a function. In Python, it starts off with this keyword def, which means essentially define a function. And in this case, we're going to define a function that says, say cheese. That's the name of the function. After that, there are these two parentheses. These are what we call, this is where we put our parameters normally. This function is not going to take any parameters, so we don't have to put anything there. And then in Python, to close off our function, we do this colon. And then we see this indentation here. We've seen this before with Python. When we want things enclosed in a code block, in Python, we indent. So to be part of this function, it has to be indented this amount. And once we stop that indentation, it's going to stop our function. So we want our cheese function simply to print cheese to the console, and then we're done. We have now written and defined our function say cheese. So let's go to our console, having saved our functions, Python functions.py, and let's go ahead and try to run our program here. It runs, there are no errors, and yet nothing is printed to the console. And that goes back to my discussion of the fact that there are two stages to a function. There is the defining of a function, what we've done here, but then there's also the calling of the function, which we haven't done yet. So let's go back to our code. Once we've defined the function, we can then just type say cheese anywhere we want in our code, passing it no parameters again. And now, whenever we type say cheese, it is going to call our function and repeat the process of our function. So we come down here and we run our program again, and now we have cheese. And in fact, we could then go on to do some other work, right? We could say, okay, print something else. Let's do some math. 35 plus 42. Num equals 35 plus 42. And let's go ahead and print out num. And then let's go ahead and call our function again. My point here is we could do this on and on and on, right? We have written a function now that we can call anywhere we want in our code. So if I come back down here, we're going to say cheese, we're going to print something else, we're going to print out number, which is 77, right? 35 plus 42, and then we're going to say cheese again. And we could keep on doing that, keep on calling that function as many times as we want. We have now broken out a piece of our code that we can now recall whenever we want to call it, and we don't have to rewrite that code, and we don't have to write a loop or rewrite a loop multiple times, right? Because the loop does allow us to call code multiple times, but it doesn't really allow us to do kind of different things in between the calling of that code, right? It calls the code, it calls the code, it calls the code, all kind of in sequence like that, one right after the other. In this case, we can write out some code that we can then call whenever we want, if we want, when certain parameters call for it, right? So we've now like separated out that code and we've built it for reuse. Generally speaking, some good rules of thumb. You want functions to do one thing. You don't want functions to be too complex. You want to break out into functions whenever possible. The reason being, if functions only do one thing, then whenever you need to do that one thing, you can call on that function. So generally having functions do one thing is a really good idea. If they start doing multiple things, then you end up writing multiple functions, some of which do repeated work. And you end up writing all these different functions that do some of the same work, but a little bit differently. Whereas if all of that was broken out into different functions, you could pick and choose which functions you wanted to, and then you could compose whatever kind of work you wanted to do, right? Your script could be composed of all these little functions that each do one thing. So generally a good rule of thumb is have your functions do one thing, and when you can, break out into a function. If you think, hey, I'm going to do this more than once in this program, I should write a function for it, right? 2 or more times, I think, is a good rule for I should write a function for it. I don't think you get too heavy when you're sort of breaking out into functions. I think you're more likely, at least as a beginning computer science student, to get caught up in writing things that aren't separated into functions and then sort of ending up with this huge procedural program where it could have really been simplified if we just pulled a few things out into functions. Okay, so that's functions.